Hello there, welcome to my channel on chemistry lessons. This is an A-level chemistry video and it's going to look at naming alkenes using the IUPAC rules. So by the end of this video you are going to be able to name these 4 alkenes. I'm also going to give you some extra ones to have a go at yourself and we'll go through those answers. First up though, if you don't subscribe, please do. Your support is very much appreciated. Please use the like and the comment features and let me know what you think. Okay, so some rules then. So when we name substances, as you've seen in the previous videos, we have something called a suffix, a stem and a prefix. So for example, we've got 2-methyl-pent-2-ene. The 2-methyl is a prefix. The pent is the stem, which is telling us the number of carbons in the chain. And then the suffix in this case is now ene because of an alkene functional group. So the suffix is telling us that functional group. We're also going to look at these 2 names later on in the video and see if we can draw them based upon the name. Best start with an example then. So here we have a fairly straightforward example. So what we need to do is identify the longest carbon chain. Now, the longest carbon chain must include the functional group. And we'll see a couple of examples later on where that kind of can cause an issue for some students. But this one's fairly straightforward. The longest carbon chain is 3. So our stem here is pro. And we know that it's an alkene, so we're propene. So it's propene here. And there's no side groups to speak of, so there's no prefix that we need to have. You may see some textbooks call this prop-1-ene. And that's to show the position of the functional group. But I'm going to argue that even if we put it here to the right, that's still prop-1-ene because we do have to use the lowest numbers. And just remember that we can number the carbon chain from left to right, 1, 2, 3, or we can label it from right to left, 1, 2, 3. So if we do move that double bond to the right, it would still be classed as prop-1-ene because we have to use the lowest number. So if it's between 1 and 2, it's prop-1-ene. If it was between 2 and 3, we'd call it prop-2-ene. But as I've just pointed out, that between 2 and 3 would be classed as between 1 and 2 if we ordered it in reverse. Okay, so this would be classed as propene. We don't have to give the number 1. But if you were to call it prop-1-ene in an exam, you would still be given the marks. Slightly more complicated example, this one then. So again, we can recognize it's an alkene, so we know it's going to have the suffix ene. But what we need to do now is identify the longest chain. Now, there are several possibilities here. We could just go straight through the middle, and that gives us 4. We could go this way, and that gives us 4. There's also one other possibility, which is this way. Whoops, wrong colour. Let me change that colour. So we could go this way. There we go. So there's 3 possible 4 carbon chains there. Now I'm going to eliminate that purple one. And the reason I'm eliminating the purple one is because the longest chain must include the functional group. The functional group being that double bond. So that double bond has to be in the longest chain. So we had 2 possibilities there. It was either straight through the middle or it was this way. And both will give us the same answer. So let's start by naming the red chain. So that's bute. So it's butene. And I do need to consider the position here. So let's have a look at the position. So we've got 1, 2, 3, 4, and I can number it in reverse. 1, 2, 3, 4. So this is but-1-ene. We can't call it but-3-ene because we have to go with the lowest number. So it's between the 1 and the 2. The double bond is between the 1 and the 2. That's the lowest numbers. So we don't say but-1,2-ene. We just say but-1-ene. That's telling us it's between the 1 and the 2. So but-1-ene. And that's going to take into account this part of the molecule. So we do have two side chains here, and they're both methyl. So it's a dimethyl butadiene. And I also need to number the position of these chains. And again, because I've decided that number 1 was at this side, and then this was number 2, this was number 3, and this was number 4, this is in fact 2,3-dimethyl. So 2,3-dimethyl butadiene. If we were to name it using that other route that I suggested was possible, we will get the exact same name. So we go this way again, 1, 2, 3, 4, or 1, 2, 3, 4. It's still going to be classed as butadiene. It's still 4-carbon chain. This time the side chains are here and here, so it's still dimethyl. And this was number 1, 2, 3. So again, it's still 2, 3 dimethyl. So as long as your longest chain contains the functional group, if there is more than one possibility, you're still going to end up with the same name. So don't panic if that is the case. Next example then. Longest possible chain here. 1, 2, 3, 4, 5. And there's the functional group. It's an ene. So it's pentene. Now let's number them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm going to call this pent1ene. Because the functional group has to have the lowest number. The functional group being the double bond. So I have to call it pent1ene and not pent4ene. So that's pent1ene. So that takes into account most of this molecule. We do have a side chain though. It's a methyl. Now I've got to make sure I get the correct number. 3. Oh, so it's 3 or 3. So it doesn't really matter, but if these numbers were different, how do I decide which number? Well, we already decided this was number 1. So 1, 2, 3. So 3 methyl pent1ene. So that's telling us the position. It's not telling us that there are 3 methyls. It's telling us that there's 1 methyl on the 3rd carbon. Next then, so here we have a cyclic group here. So there's 1, 2, 3, 4, 5, 6. 6 carbons in a chain. So it's cyclohexene. Cyclo because it's cyclic, hex because there's 6, and ene because there's a double bond, cyclohexene. Now I think that might actually be beyond the specification at BTEC, but it's there. We'd rather be over-prepared than under-prepared. So there's cyclohexene. I don't need to name or number the position, because it doesn't matter where it is. If I was to draw the double bond here, then it's just the same thing that's being rotated round. All we've done is rotate it round. It's still the same molecule. So hexene, cyclohexene. Right, what I'm going to suggest you do now then is you're going to pause the video, and when you're ready to see the answers, unpause the video and we'll go through these. First one, be careful. So I'm going to do this one first. The longest chain is in fact 4. 1, 2, 3, 4. It's here. Okay, so it's butene, and it's but2ene. So it's but2ene. There's a side chain on the number 2, so it's 2-methyl. The side chain is a methyl, so 2-methyl but2ene for the second one. For the first one, second one. Right, I've been awkward here because the longest chain is 5 right through the middle, but it doesn't include the functional group. So it's not in fact the longest chain, because the longest chain has to include the functional group. So the longest chain this time is 1, 2, 3, 4 again. Number them 1, 2, 3, 4, or 1, 2, 3, 4. Got to go with the lowest number for the functional group. So this is but1ene. So but1ene. And this time the side chain is an ethyl group. It's a C2H5. It's ethyl and it's on the number 2. So it's a 2-ethyl but 1-ene. Right, the third one then. Longest chain that contains the functional group is 1, 2, 3, 4, 5. Let's number them. 1, 2, 3, 4 and 5, or in reverse. 1, 2, 3, 4, 5. So this is pent 2-ene. So that's the pent 2-ene there. And there's 2 ethyls. 2 methyls. So it's dimethyl. And I need to number the positions of the methyls. It's a 2, 3, dimethyl pent 2-ene. Final task then, see if you can draw these two molecules. When you're ready to hear the answer, unpause the video and we'll go through it. Pent 2-ene, so that's 5 carbons in a row, 3, 4, 5, and there's a double bond between the 2 and the 3, and then there's a methyl group on the number 2. There we go. That would be classed as a 2-methyl pent 2-ene molecule. Now just a little tip, it's tempting sometimes, or it's easy to make a mistake and put either too many or too few hydrogens on when we draw these out. So a little rule or little tip is make sure that all your hydrogens only have one bond, which is quite easy to do. And then, though, this is the mistake that people make sure your carbon only has 4. And it must have 4, not 3, not 2, must be 4. So count your carbons, particularly where you've got your double bond here, look, you've got 1, 2, 3, 4 bonds. Sometimes I'll see students want to put an extra H here, and that would be wrong. Okay, finally then, 2, 4 dimethyl, 3 ethyl, oct 3-ene. That's a bit of a mouthful. So oct is 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's my 8 carbon chain. A double bond between the 3 and the 4. 1, 2, there we go. Double bond there. A 2,4 dimethyl, so there's number 2. There's a methyl group. 2 and a methyl group on the number 4. Doesn't matter whether I draw these groups above or below. So, and then we need an ethyl on the number 3. 1, 2, 3. So an ethyl is a C, C. I'm not going to draw all the hydrogens on here, but again, just make sure you follow the rules. I'll put a bond to each of the hydrogens. Just make sure that each carbon has 4 bonds and hydrogen each has 1. Again, it's tempting around the double bond to put an extra one in there. And that's the end of this video, so thanks very much for watching and good luck.